Water is, of course, also important for transporting substances in the blood, and there are many types of substances that have to be transported. Specifically, you can categorize the substances in so-called the hydrophilic substances and the hydrophobic substances. The word hydro refers to water, and philic means loving. So these are the water-loving substances, and they dissolve well. And the hydrophobic substances do not dissolve as well in water. Hydrophilic substances generally are polar, so this means they are attracted to water. And some of them, if they're small enough, are also soluble. That means if you, for example, take some salt and if you put it into water, then it dissolves. You cannot see it anymore, and it's still in there, of course. But essentially, it's surrounded by water molecules, the individual salt ions, and therefore it dissolves. And the salt is polar, of course. It carries a charge. Hydrophobic substances are non-polar. These are, for example, fats and oils, and they do not dissolve well. Well, if they're small enough, they do dissolve a little bit, but not very well. So blood is not able to directly carry the hydrophobic substances as well. So now let's have a look at some of these substances that have to be carried by blood. And what we have down here is the substance, sodium chloride, glucose and amino acids, oxygen and cholesterol. And sodium chloride, NaCl, when you put it into water, the sodium chloride dissolves, it forming positively charged sodium ions and negatively charged chlorine ions. So sodium chloride is really polar. And therefore, right down over here, the polarity is high. And now how is it transported? It is transported directly dissolved in the blood plasma. In the blood plasma. I just write plasma because the blood plasma is, of course, contains a lot of water. And that's easy to transport it. Glucose and amino acids are also small enough, and many amino acids are also polar, and even the non-polar ones are generally or often small enough also to be able to be transported by water. Maybe not so well as the polar ones, but maybe still possible. But glucose definitely. So the polarity of the amino acids, we also say that it's generally high or higher of glucose and amino acids. And how is it transported? Well, I'm going to make it really easy right now. I'm just going to draw it like this. It's the same. It's dissolved in the plasma. So if you wonder about the amino acids, I'm just going to draw over here somewhere on the side. I'm going to draw you the chemical structure of an amino acid. C, you have the C, you have the double bond O, OH. You over here have an R group. An R group over here. Down here you have a hydrogen. Over here you have an amine group with two hydrogens. A little bit too small. But that one over here is polar, and this one over here is also polar. And if the R is sufficiently small, then the whole thing here is polar, and so it can be transported quite well. Now, what about oxygen now? Now, oxygen is an interesting case because oxygen is O2. And if you look at the structural formula, it's oxygen double bonded to oxygen. And the charges here, they balance out. Even though oxygen is quite electronegative, they pull electrons equally. So overall, it is quite neutral. There is no charge distribution, so the polarity is low. And this is the reason why we are not able to breathe oxygen, which is underwater, is because water is not able to dissolve oxygen very well. So what we need is we need now a hemoglobin in the red blood cells, and the hemoglobin binds the oxygen, the molecular oxygen, the O2. Okay, so we need an additional help here. Now, does oxygen dissolve in water? Yes. I mean, fish, of course, are able to breathe, so to say, underwater, because the oxygen which is dissolved in the water can be taken out by the gills of the fish, but there is not a lot of oxygen in there, or it does not. At least it does not dissolve very well. And also cholesterol, what we have down here, cholesterol is a lipid, and of course the polarity is quite low. So it cannot be transported very well directly dissolved. So the cholesterol is transported by so-called lipoproteins. by lipoproteins. And basically, to make a really simple drawing, what you have is you have the cholesterol in the middle, yeah, and then you have surrounding the whole thing, you have a membrane and or protein structure, so that basically the cholesterol in the middle is not in contact with the water surrounding it. Okay, so these are little packets, and that's basically how it's transported in the blood. But the cholesterol is generally not directly transported in dissolved form because it does not dissolve very well. So that is basically it. Okay, so you have to know the difference between hydrophilic and hydrophobic, and simply by looking at the substance, ask yourself: is it polar or is it non-polar? And if it's polar, if the polarity is high, then it is hydrophilic. That's something you might want to write down as well. It's quite easy, okay? These are hydrophilic, and cholesterol is quite hydrophobic as well, and oxygen also somewhat. Okay, so yeah, know the table.